In the coming hour, we'll present you the rationale behind multicast ABR, the various business cases, where it is strongly relevant, and how it is currently specified at DVB. This DVB webinar is the first of its kind. While previous webinars focused on presentation of DVB specification, this one will be centered on market aspects for this new technology. It was in particular motivated by a set of questions raised in March following the webinars prepared as an alternative to DVB World, cancelled because of COVID-19. So I'm Christophe Burdina, chairman of the MABR task force, in charge of reviewing the existing commercial requirements and gathering new commercial requirements as a first stage before a new specification cycle. I am very glad to introduce this webinar prepared with the help of three eminent MABR experts, representative of three companies, very active on the specification front at DVB. William Stovar, my colleague, Solution Presale Manager at Enensys, Julien Lemoteau, Standardization Expert at Orange, and Xavier Leclerc, VP Business Development at Broadpeak. And last but not least, Emily Dobbs, Head of Technology at DVB, is also with us and will be able to answer our questions. So first, as an introduction, I will provide a quick reminder about what is multicast ABR and where does it come from. And then we'll take the time to present and introduce 4 business cases. And for each of them, we'll discuss again, broad by MABR, its impact on the architecture and the existing challenges. And finally, we'll have a look on how MABR is addressed at DVB, its standardization status, and the expected future work. So one last word before we start. As we'll see different business cases for heterogeneous markets, it feels to us more practical to take a few minutes after each case presentation for question and answers. So we strongly invite you to write your question down as soon as you have some, so that we can address them immediately. And we'll also try to save some time for an ultimate set of question and answers at the end. So that said, let's start. What is MABR? Well, I do think that the huge majority of you are already quite familiar with the concept. So as a quick reminder, let's recall the following. ABR has gained momentum in the latest decade because it addresses the following points. It's based on HTTP, so it's easily deployable on all networks, even on the ossified ones. It's capable to let the receiver seamlessly switch from one representation to another following the variation of the link capacity. And so several representations of the same service are split into segments and made available as file over HTTP. So delivering an ABR service implies to duplicate the streams. One stream per receiver, basically, whatever the access network. A video on demand is consumed over unicast, one stream per viewer, as we can see in blue. A live service consumed on TV requires also one dedicated video stream. And any other devices in the same home will require their own dedicated streams. And so ABR distribution can have a massive impact on the core and access networks. We know that live ABR service can have important peaks on bandwidth, especially for popular events such as live sport, as illustrated in this graph from BT, showing in red a big peak corresponding to a rugby English Wales game. And the overall throughput, you can see here, has almost doubled during the peak. And such peaks jeopardize the quality of experience and of viewers. There is less available bitrate, there is worse video quality, some rebuffering, and at the time, viewers are the most demanding. This is the first motivation. And the second it is that MABR allows to reach all screens, including TV, meaning that the operator won't have anymore to double their equipment to address both TV with IPTV and other devices with ABR. So what becomes our schema with multicast ABR? For on-demand services, it will still consume over unicast, as shown in blue. And for multicast service, a multicast server fed by the origin server delivers one stream only. And generally speaking, the multicast server streams the representations with the highest quality in the end user premises or close to the end user premises. A multicast gateway can receive this multicast stream and will act as an HTTP proxy to feed the legacy and unicast ABR clients. And by delivering with MABR, the service provider ensures the best quality of experience at the time it is the most demanding. So I will now give the floor to our panelists. And we'll start with Williams. Williams, I hope you're ready. And and the first use case we'll see is OTT over satellite. Williams, the floor is yours.
Yes, thank you. Can you hear me?
Yes, we can hear you. Okay,
perfect. Hello, everyone. Thank you for being here with us today. My name is William Stover, and I work for NNC's Technologies. And the first business case I'm going to introduce to you today is OTT over satellite. As you might know, today satellite TV services are delivered to homes for consumption mainly in the living room TV sets. Most of our satellite operator customers are telling us that they are currently delivering broadcasters programs in their regions using DTH, and they want to use part of their satellite bandwidth to deliver some of the existing channels in OTT to countries, probably in Africa or in Latam, for example. They are targeting users with tablets, smartphones, or PCs, or any connected device. And I would say that they are certainly right, because as a matter of fact, according to a report from Ericsson Mobility Report, in 2017, already 70% of consumers watch a TV and video from a smartphone. And the trend is going up. Mobile video traffic continues to grow, okay, and is forecasted to double from today up to 2022. This situation could represent a threat for our satellite service providers or satellite operators, customers, if nothing is done. They could lose market shares from competition, offering access to video streaming services from mobile devices. In order for satellite service providers to compete effectively and capture market share in this sector, transforming this potential threat into an opportunity, DVB multicast ABR can help. In order to offer video streaming services over satellite today, it is necessary to implement an OTT headend consisting of basically a transcoder and a packager. The transcoder will be necessary if you don't have the capability to produce ABR type of streaming HLS CMAF in the existing encoder you have. And this will fit a DVB multicast ABR server that will encapsulate the streams coming from the origin server into an IP multicast flow with flute and route, which are the protocols that are so far specified by DVB. And then this IP multicast flow will then eventually go into a satellite gateway encapsulating in MPE for IPTS. And you could introduce this OTT flow into a PID that you can reserve into your multiplexer to be sent over the satellite link. In the home network, the satellite receiver will include a multicast gateway for the conversion of multicast into unicast and serve the multiple end user devices in home. Okay, the benefits for the satellite provider are mainly to satisfy the appetite for streaming video from different screens, as I said before, and to bring a solution to reduce cost versus broadband in some cases, because broadband in unicast today will grow as the number of users grow. When you have popular event, you will need a lot of resources on your CDN cache. You need to scale, so you need to invest. So doing this with satellite, you have a fixed price, fixed cost of your satellite link, and then beyond a certain amount of average usage per month, you could pretend to have a gain from the satellite link. The other advantage of satellite is the possibility to deliver OTT in places with no broadband today. There is a lot of places like in Africa or in Latin America that have a very low penetration of broadband. And this kind of use case could benefit in those cases. Another important benefit for the service provider, the satellite service provider, is that it could cover B2B as well, extend its services to serve B2B places, to put public gateway with a multicast gateway, delivering people in malls, in hotels, or ships, and you name it. And another important topic is that implementing DVB specified interface and protocols will enable operators to create future-proof network, because they can make their networks evolve with providers and new functions of their choice. They could, for example, integrate a variety of home public gateways and multicast gateways providers supporting the DVB specification, and avoid to stick with only one. To conclude on this business case, we have, of course, some challenges. The main challenge that I identify for this OTT over satellite is the device integration. Of course, if you are a satellite service provider, you might want to keep your legacy decoders, your legacy boxes, and then you have to kind of integrate this new device into your ecosystem. And this, of course, requires some work. That it's not impossible, or far from that, but it's something that you have to forecast. And that's it for this business case. Now I'm open for questions, if there is any.
Yes, Williams. One question from Sridhar Sethi. I hope I pronounce it well. What is the latency introduced because of additional encoding and processing of MABR content in the headend?
Well, basically, if you can use CMAF chunk encoding to transmit your content, and in this case, you can, excluding the delay or latency introduced by the satellite, you could pretend to have latencies that are very similar to what you have today in IPTV, or even in the digital terrestrial television. So I don't know if this is enough as an answer.
I guess the low latency aspect are also addressed in the following business case. So
exactly,
I guess it's okay. One other question that I've been seeing is, what about GSC? Because here on the architecture you show only MPE.
Yes, that's correct. I mean, GSC is a protocol that you will use when you are transmitting IP over multicast. In this case, I put the example of MPE because MPE allows you to encapsulate into an MPEG transport stream. If you, of course, have the possibility to introduce a content without keeping the legacy of the MPEG-TS, you could directly transmit over IP, and then you could use the protocol, the GSE protocol, in order to encapsulate it and transmit it over your satellite link.
Okay, we can take one other question. Do we need a second transponder?
Actually, it all depends. Normally, the broadcaster has control on his transponder, on his bandwidth. We could imagine that the broadcaster, depending on the strategy he wants to take, he can, for instance, replace very popular, low popularity content by an OTT service or several OTT services. Generally, an MPEG-TS link for DTH takes about 3-4 megabits per second. If you want to serve only screens, small screens like smartphones and tablets, you probably are looking at, let's say, 1 megabit per second for a profile to receive content on the other side. And then the broadcaster can take the decision to replace, for instance, SD or some profiles in the existing transponder, and not to have to introduce a new one. It all depends on how the management of the bandwidth in the transponder is made. So okay, that would be my answer on that.
Thank you, Williams. There is a couple of questions still in the
okay, I will take a look.
I will let you take them offline. Okay. We need to move on the following.
Okay.
So now it's time.
Okay, Christophe.
Sorry, Christophe. Your microphone was accidentally muted by me.
Oh,
off
okay.
You go.
Okay, I was saying there's some questions still in the inbox that will work offline. And now we'll move to Julien for the following business case, next generation IPTV.
Hello, everyone. Julien Lemotte from Orange. So I will introduce the next gen IPTV use case. So to understand how multicast ABR will improve IPTV, let's remind what IPTV is. IPTV is a mature and proven solution where streams are delivered from the TV headend to a set-top box. The main criticisms we can do on IPTV are the necessity to have a specific headend reaching only the operator STB, and the cost of this STB mainly due to the cost of the chipset and the cast security. Another point is also that today innovation is driven by the OTT technologies ecosystem. The same innovations are possible on IPTV, but it requires expensive and time-consuming custom developments. So the question is not if OTT will replace IPTV, but when OTT will replace IPTV. Until now, the advantages of IPTV on the scalability and the latency makes that for operators having a managed network, it was not relevant to drop IPTV. But things are changing thanks to semi-flow latency, which solves the latency issue, and multicast ABR, which solves the scalability issue. So while multicast ABR is a good solution for IPTV operator, there are two scenarios. The first one consists in integrating the multicast server in the headend and the multicast gateway in the STB. With this scenario, we take advantages of the OTT and IPTV ecosystems. The OTT headend delivers dash streams over multicast until the STB. This allows to unify platform as we use the OTT headend and the OTT service platform. The cost of the STB is reduced because we use an OTT chipset and DRM. On our side, we believe in this solution, but we will still have to clarify points before considering deployments. There are no blocking points, but we need to design the solution with care. For example, to be quickly economically profitable, the compatibility with existing home gateway and STB, but also the integration with our current supplier are important topics. The standardization should help us on this point. Secondly, DRM are secure enough to replace case. but we will have to take care on accountability when a content security breach occurs on our devices and the parental control management. Finally, the sizing of the OTT service platform has also to be redesigned due to the increase of the number of devices and the addition of requests for some information formerly managed in IPTV streams, like licenses delivery for decryption. But we still have an issue with this scenario. Only the operator STB is reached. This can be optimized by hosting the multicast gateway in the home gateway. In this case, the multicast stream stops at the home gateway. The only requirement on playback devices in this scenario is an ABR player. This allows to be compatible with all devices in the home. In addition of optimizing IPTV delivery chain, it also allows to reduce the delivery cost of live streams on high audience channels for OTT devices. Another important point is that it improves the quality of experience on these devices thanks to the managed network. For a network operator, this could be also a way to monetize its managed network by giving access to streams delivered over multicast to third-party applications. And thus, it could reduce peak on the network during high audience live events, whatever the application provider is. The reduction of our environmental impact, along with this solution, is also one of the ambitions in Orange strategy. Some additional challenges appear with this scenario. Current home gateway CPU haven't been designed to manage such conversion, and additional load could impact other services provided by the home gateway. The multicast gateway integration will be probably more challenging than on STB, especially for operators who don't manage the middleware of their home gateway. We're also investigating some other non-trivial points, like the hosting of the HTTPS certificate, which is mandatory in order to be compatible with some devices like browsers, or how to allow targeted advertising on multicast ABR streams without having peaks of unicast traffic during the delivery of these ads. I hope it was clear. And Christophe, did you receive some questions?
So there are still some questions in the inbox, but I related to the previous one. But one question that is often raised is what is the impact on the setup box for the first? If we look, yes, in the first scenario.
So we have to integrate the multicast gateway. It can be a piece of code from a multicast ABR solution provider. So it has to be integrated in the middleware of the STB, which is provided by another supplier. So it could be quite complicated to maintain this solution. But with the standardization, we hope that our current supplier will be able to develop its own multicast gateway, and so it will be just an update of the current IPTV set-top box. And on set-top box, we won't have any issue on the powerful on the set-top box. It's enough powerful, which is not the case on the home gateway.
One other point. So, is it from Aftab Hanif? I'm not sure if it's related to this one. Is it used in MPLS-based networking? So,
if you can help me on MPLS,
I guess you would be able. But then, I mean, I think we'll skip this one, and I will need to check that.
Maybe just to try and answer this, Christophe.
Yeah,
yes. So MPLS will be used to transfer multicast, just like you use MPLS to transfer multicast IPTV. You will use the same MPLS routing infrastructure to transport your multicast ABR streams. Yes.
Thank you. So. How much time do we have? Yes, we can take one over. From a business angle, question from Murzi moi qui l'ai dit. From a business angle, is there a cost saving on both the OTT provider in terms of the CDN costs and MNO or ISP in terms of bandwidth costs and achieved by introducing multicast?
Yes, with multicast ABR, we will have cost savings on the cost of the STB for the launch case if we supply the device, but we will also have some cost savings on the CDN because we reduce the peak of delivery on high audience live events. So we will have cost savings here. And we will also have cost savings, not cost savings, but we, as a network operator, we could monetize also our managed network. So we could also be able to do business, additional business, also with this solution. But also, it's not only about cost savings, it's also about quality of experience on OTT devices. So the video traffic for these devices won't be mixed with internet traffic. It will be possible thanks to the managed network. So the quality of experience on OTT devices will also be improved with this solution, which is another important point, like the cost.
Okay. It's time to move on. There is still one question
Okay. I will
in the inbox, so I will let you answer offline. So now it's the turn of Xavier and the following business case: scaling ABR delivery.
Okay, very good. Let's see if we can see my screen. It doesn't seem to work, does it? Okay. Christophe, maybe can I suggest you you present my slide? That's okay.
Yes.
I don't know why they don't seem to be appearing. Typical, you know, you get everything ready and then something doesn't work.
It's coming. You can start.
Cool. All right, so let's start. Apologies for this. So my name is Xavier. I run the business development team at Broadpeak. Broadpeak is one of the pioneers of multicast ABR solutions. And bouncing on what Julien just explained with the next generation IPTV, I'm going to talk about a similar use case, something I've called scaling the adaptive bitrate delivery. And this is one of the biggest drivers for network operators deploying MABR. So first, I wanted to take a look at the landscape of video delivery today, right? We know that adaptive bitrate or ABR streaming is gaining ground. And when we say ABR, we mean chunked video, right? As opposed to a transport stream. So you can think of ABR as chunked video. And if you look at where ABR is today, I mean, it's very clear. It's being delivered to all screens, right? Whether they are set-top box, tablets, smartphones, or connected TV. ABR technology also powers nearly all the non-linear video use cases with start over TV, catch-up TV, network PVR, and all the video on demand offerings. And you see ABR obviously allowing content personalization, so very popular applications for targeted advertising, for example. So I think it's fair to say that ABR is where we see a lot of innovations today, and more generally, ABR is the natural future of video delivery. Okay, so Christophe, you could go forward. Having said that, basically, ABR has not yet replaced broadcast for live TV. If you look at the live video delivery today, it is still done with broadcast technologies. And why? Because there are two main problems for ABR's adoption for live TV. The first one is the scalability. So this is what Julien mentioned. By default, ABR uses unicast traffic. So as there is more demand from the consumers, there is also more traffic in the network. Networks have to carry more traffic. And these networks were never really dimensioned to deliver individual streams for all the concurrent viewers at the same time. So there is an issue here. There's not enough bandwidth being available. And then secondly is the quality of experience, right? So we hinted on the topic already, but quality of experience is, is still an issue today with ABR. It is not as good as broadcast. And when you think about it, broadcast is a very tough benchmark because it is basically always available. It never buffers and it has a negligible latency. So a good benchmark to aim for ABR. Just to sum up on the ABR, the point here to highlight is that the problems are coming from the unicast distribution and not from the ABR format itself, right? I think it's important to stress this. So here, right, we're introducing multicast ABR and its ability to scale the ABR delivery. So if I'm a network operator today, I offer video services. Chances are that I'm delivering content to multi-screen devices and therefore already using ABR technologies like HLS or Dash. To do this, I basically need to scale my network to be able to carry a large amount of ABR traffic. And I need to deploy a content delivery network, a CDN, capable of serving all the streams. Very simple math, right? If you have 100,000 subscribers, concurrent subscribers, each watching the same, let's say 4 megabits per second stream, you instantly need a CDN capable of delivering at least 400 gigabits per second, right? So very quickly you can arrive to relatively large volumes of traffic. So the idea with ABR, with multicast ABR, is that because you use multicast, there's only one stream that gets replicated by the network. The stream is made of ABR video chunks that are being encapsulated by the multicast server. They are being transported through the network to the subscriber's home and then decapsulated by the multicast gateway for distribution. And both components are standardized by the DVB specification. What's important here is that the rest of operation, both at the head-end side and both on the client side, are completely normal. We do not touch those environments. So it's very much a transport mechanism for the network. Okay, so this is scaling multicast ABR. Why is it relevant? They are, if you can go forward, Christophe, please. There are a number of drivers here, right? The first one is we see network operators introducing services across all screens. Give you two examples here. First one is Liberty Global launching, for example, a UPC TV in Switzerland with a very much a bring your own device model. You can have your video subscription on any device you may want to use at home. Or even more specifically, in the case of Bouygues Telecom in France, a TV service targeted to connected TVs, right? Where basically the complete TV service of Bouygues Telecom is now being offered on the Samsung 4K smart TV, and it becomes a set-top box-less TV service. Very, very interesting. And it's very interesting. Why? Because the main aspect here is that the video is delivered to the first screen using ABR. The big TV in your lounge is now consuming live traffic over ABR. And this is where it leads to large amounts of traffic delivered by the network, delivered through the network, sorry, by the content delivery networks. And if you know a little bit about CDN, you will be familiar with the concept that on-net CDNs are usually licensed on maximum capacity, right? That's the maximum bandwidth the CDN can deliver. And with multicast ABR, we avoid peaks due to live demand, and therefore we reduce the cost of CDN on top of the network cost. Okay, so we basically save bandwidth and we also save investment in the CDN. MABR, if you look at it, is a more efficient approach, right? I think Julien mentioned it already. It gives a reduced carbon footprint as there are fewer servers deployed to handle the peak of traffic. And generally speaking, given that multicast provides the underlying transport, it guarantees the delivery of content, right? So if you move to the next animation, Christophe, here we go. It guarantees the delivery of content. So therefore, services in higher bit rates may be offered, right? MABR can enable the introduction of a 4K service in some networks, for example. And more generally speaking, MABR is improving the quality of experience. Since the delivery is guaranteed by multicast, the buffers on the clients can be reduced, and this in time minimize the latency on playback. This is one of the biggest impact when it comes to latency, how much your ABR client is buffering. And if you're confident that your network will deliver the content, you can then reduce your buffers on the client. Okay, so this is multicast ABR to scale the ABR delivery. In terms of challenges, I think this has been mentioned twice already. The main challenge is integration of the multicast gateway function inside the home gateway. It can be a challenge. Okay, can you still hear me?
Yes.
Yes, we hear you now. We
There was a little bit of a
lost you
glitch.
for a little while there. Yeah.
All right, sorry. So
You
I
were
was
just
saying
talking about the challenges.
challenges. Okay, all right. Sorry about that. Don't know what happened. There was a little glitch on my side. So yeah, challenges is the integration of the multicast gateway function into the home gateway. If you have multiple models of gateways being deployed, you will have to do the integration multiple times. This can be, resource intensive. This can be time consuming, but there are initiatives to accelerate the integration in home gateways. That's the good news. And to give you an idea, Broadpeak has now about 85 devices that can host this multicast gateway function. So it is possible to deploy this multicast gateway in quite a broad variety of different devices. Right? There is a lot of options here. Also, it is common for network operators to draw the line, right? Enable their latest models of gateway is the one that have the most advanced specification. Say, for example, all the models that have been introduced in the last 12 months and all the future models beyond this point, right? So sometimes operators will decide to freeze the development on a specific models of gateway and then only take the multicast ABR function on the most recent part of their deployed gateways. Okay, finally, deployments, right? So experience shows that it is possible for network operators to build business cases for multicast ABR based on saving on delivery, okay? So taking into account savings from networking, CDN cost, both CapEx and OpEx, as I need fewer licenses and machines to deliver my traffic. We basically have deployments of multicast ABR across a variety of different networks, whether they are cable, fiber, DSL, satellites, as Williams mentioned at the beginning. There are live streams that are being served today using multicast ABR. Okay, I think I'll finish with three things. So first, multicast ABR brings together the versatility of ABR and the scalability of multicast. Secondly, it's a very effective solution. So we said that it lowers the cost of playback devices, the network, the CDN, and the carbon footprint. And then finally, MABR solves the quality of experience issues of ABR, and in particular, buffering and latency. So enabling now the migration of live TV services to the ABR formats. Thank you for your attention, and I will now invite the audience to ask a few questions. Christophe, do you have any questions?
Sorry. Yes, Xavier, we don't have a lot of time to keep on with the agenda, so I will just pick one question, and I will let you answer the other offline. Sure. So one question from Kev Shaw. If the service providers can deliver the multicast to the home gateway, why they cannot deliver the multicast to the multi-screen devices as an app to reduce the latency, cost, and integration with home gateway?
Yep, so this is going back to the legacy IPTV had to evolve the legacy IPTV to multicast ABR, pushing basically your multicast all the way to the end device. It is a possibility, right? If you use your own devices, if you control the set-top box, absolutely. If you want to deliver content to a Chromecast, to an Apple TV, or to an iPhone, this is where it becomes more difficult, right? You may not control those applications, and still today, transferring multicast over Wi-Fi can be a challenge. So putting it on a gateway is a good way to get rid of the problem. You put it on the gateway, and then from the gateway, it's pure unicast out. Okay.
So we are 2 minutes late on the agenda, so we'll move on to the last business case with back to Williams. Thank you.
Hop là. I guess you can hear me now. And I'm sharing my screen. Okay.
Everything is good, Williams. Carry
Everything
on.
is good. Okay. Thank you. So yeah, coming back to this satellite delivery, actually, this is another interesting use case because in this case, when you want to deliver video streaming service, as Julien and Xavier stated before, you need, of course, a CDN network, usually in unicast, with caches distributed in different telecom operators' points of presence, and which are close to the final users, all along the regions the telecom operators want to serve. Sometimes in some regions, countries, core and CDN networks are non-existent or have low capacity. For instance, broadband internet penetration, as I said in previous presentation, can go as low as to, I was looking at that, 12% in average in certain regions of the world. And in average on the entire Earth, internet and broadband penetration is about 53%, which reflects somehow, not entirely, but reflects somehow the lack of network infrastructure. So delivering content, in particular popular events, to different POPs in the network could be a challenge when the number of users is going to grow and the operators want to expand to new regions, and there is a need to introduce new POPs. So here again, DVB multicast ABR can help satellite and telecom operators to cooperate and tackle this issue using CDN backhauling services. As in the previous slides, you, I guess, are now getting familiar with the the features that you want to introduce or you need to introduce. In this case, you can introduce again the multicast servers, and here I could have specified GSC. I think there was a question before in terms of the encapsulation. I can use it here to deliver the different operators POPs, and in each operator POPs then we'll need a satellite receiver with a multicast gateway embedded in the POP in order to deliver the different contents to the caches that are close to the final user. So the telecom operator in this case will now be able to deliver the content anywhere, okay, and overcome the problems or the limitations of its core and CDN network. It will be possible for the satellite operator to deliver to POPs not only of one telecom operator, but we could imagine that it could use it to deliver different telecom operators. And the telecom operator can, virtually be present anywhere on Earth because of the ubiquitous nature of the satellite. Here again, the way DVB multicast ABR help, I said it before, is interoperability. More than ever here, you are interoperating between a satellite operator and a telecom operator. So you need to have, again, something that, a specification that is solid enough and which allows you to do the different, the cooperation, to put in place the cooperation. Of course, there are always challenges. In this case, I identified one, which is the integration with the telecom operator POPs, of course, because you need again to deploy a satellite receiver as well as the multicast gateway interfacing with a cache server, a cache CDN, sorry. And that needs to be done across the entire network of the operator if necessary to cover different regions. That's it for me on this use case. So Christophe, if you have questions related to this.
Well, in fact, we are a little bit short on the agenda, so maybe we'll take those questions in the end if we have time.
Okay, I keep running then because the next use case I'm going to present it to you as well. In this case, we are talking backhauling the CDN for the 5G networks. As you know, 5G networks, we're talking about 5G everywhere. It's becoming a reality nowadays. For instance, again, Ericsson Mobility Report estimates that 190 million subscriptions will be subscribed by the end of this year, and we'll have 2.8 billion subscriptions by the end of 2025. So the uptake is expected to be faster than the one for 4G, so it's huge. Moreover, 5G is a fantastic opportunity for delivering new applications that are particularly bandwidth hungry. For example, for 8K television, virtual reality, 3D, we could dream of many different applications that require a lot of bandwidth, that provide a lot of immersive experience. And to make this a reality, 3GPP has worked, of course, in the 5G radio networks, making it very good at delivering high bit rates in the access part. But the thing is that if you think about it, this is going to have repercussions, of course, in your CDN and your core network again, because at some point, the traffic has to go through the entire chain. In order to face this challenge, DVB multicast ABR represents again here an interesting approach to alleviate the burden on the CDN and core network. So deploying a DVB multicast ABR server and a mobile edge computing cache geared with a DVB multicast gateway to fit the 5G network at the edge will of course drastically reduce the stress on the network by offloading the high popular events and sending over multicast, and at the same time freeing up CDN and core resources for the remaining on-demand and less popular content. So this joint action ultimately ensure the promise of the 5G, which is to deliver low latency, high quality content and higher bit rates for demanding application. And of course, here again, DVB multicast ABR is the perfect tool to complement this because of delivering this promise and of course providing interoperability possibilities with the different actors of the ecosystem. The main challenge here, I would say, is potentially the number of the caches and that you need to deploy all across the network of the operator. That will end for me this use case. So Christophe, is there any questions?
There would be some, but I think I will now more jump on the conclusion. And then if we have the time, we can take the questions related to this business case in the end.
Okay, sounds reasonable. Okay, thank you.
Thank you. So we've seen that there are several business cases where MABR is relevant. And so MABR has been considered by DVB since 2016. And in March 2018, the first version of the Blue Book was available, including the reference architecture. And in March of this year, the latest version was made available, providing in particular the protocols and the procedure for the key reference points. And this version with possible late corrections, will be the base for its publication as an ETSI standard.
Christoph, sorry
yes.
to interrupt you there. Are you meant to be sharing your screen with us? Because we are not seeing it.
Oh,
go ahead.
Sorry for
Thank
that.
you.
Yes. So I was saying that the latest version of the Blue Book will be the base for the publication of the ETSI standard. It's expected really soon, and it's basically a matter of weeks. So if you need an introduction to this Blue Book, there is an excellent webinar prepared by Guillaume Bichot and Richard Bradbury, chairman of the TMM task force, in charge of, in particular, of MABR specifications. So many of you have probably already seen it, but if it's not your case, we can only highly recommend. Since May 2020, DVB is discussing enhancement and new features and new commercial requirements for a second phase of specifications. And many topics are cross-cutting with other DVB specifications. Target advertising is a good example. Target advertising is a feature already addressed, but its ability to inject targeted advertising during commercial breaks of live content delivered over multicast ABR, it's a very interesting case, because what shall be avoided is that everyone would fall back to unicast at the same time to download their targeted ads, which would cancel all the benefits of the bond wipe. So it's a nice thing to address. Another case is to be able to deliver live content over MABR and over a unidirectional link like satellite. Like satellite. And so it's cross-cutting with the native IP initiative, with also DVB-I for service discovery and metadata. And I would conclude by saying that the fact that these topics are cross-cutting at DVB, it's also the sign that DVB is the right place for this next step of MABR. As I said, the scope of phase 2 is not 100% established yet. We are gathering and discussing inputs, use cases, commercial requirements from the market for the next phase to help the adoption of MABR. And we, as a whole, will welcome your views and your consideration to help consolidate this thing. So, and I think it seems to be the perfect transition now for a last round of questions and answers. Thank you. So, I think, Julien, you wanted to respond to one particular point.
Yes, I skip a question. It was from Jan. Are there existing deployment of CMAF over multicast ABR? What would be the expected latency in this case? So maybe Nancy or Broad pick you are the good.
Yeah, I can take that.
Okay.
Yeah. So there are no deployments yet of CMAF and multicast ABR together. The reason for that is the client support of CMAF is still patchy, and you need to have all of the client supporting CMAF to be able to deliver the service across all the devices. But this is something we're expecting to see coming in the next, let's say, couple of months. You know, this is something that is in the pipe. And insist maybe, I mean, that's
yes,
my perspective.
I was saying, sorry, I was in mute. Yeah, I was saying the same thing. I mean, there are probably some deployments already in unicast, but in multicast, it's not something that is done yet because of the ecosystem needs to be put in place. But I would say that, yeah, the solutions are ready and it can be deployed on the multicast ABR side.
Another question which is also often raised is, can DVB-MABR be used over 5G? And I think I will answer this. So 5G broadcast has been just has been specified, and 5G broadcast allow to transparently deliver IP streams over broadcast. And yes, it's true that MABR is considered currently at 3GPP to be used as a delivery stack over 5G broadcast. And we can also mention that we have an activity initiated also at DVB to address those points. And so there is a new task force related to delivery over 5G. And one other question we can have is when DVB-MABR will be available in products. So I let Xavier and William answer.
Yeah, from NNC's standpoint, we have already products that can be commercialized and are ready for deployment. But I guess, again, it's a matter of ecosystem. The ecosystem needs to be ready as well on the telecom or satellite operator side in terms of the availability of the home gateway, satellite gateways, and of course, all the challenges that were mentioned by Julian and Xavier during the presentation. But in terms of products running and available for commercialization, we can say that we are capable of providing that already.
I think the question was more about DVB-MABR support than multicast MABR support.
Oh, okay. It's about DVB-MABR.
Yeah.
Well, I would say that our products are, there is a certain percentage of DVB compliance. At NNCs, we have products, for instance, running already Flute and Route, which are the basis of our activities in ETSI and 3GPP. So, but it's true that there is still some work to do because the standard is available since I think it's February this year, January, February, the final set. So it takes some time to.
I don't know, Xavier, you may want to answer also. Unless
yeah, sorry, I missed the question, but I guess it was related to a DVB
availability of DVBR. When will have DVB-MABR products ready? That's it.
Yeah, that's a good question. I think it's an ongoing process, right? You know, there are different ways of transporting the video. I think Williams was just talking about it, different transport protocols, different ways of doing it. At Broadpeak, we have made some technology choices that may not be 100% compliant yet with DVB, but, you know, it's an ongoing activity to align this on both sides, you know. So yes, it would be, you know, we're very much aiming to have a fully compliant solution at the end.
Yes. So I guess the hour is over. I would like to thank the panelists for their helps into preparing this this webinar. I would like to thank also Ewan and Emily for their support and their impulse, and also all the attendees for showing up their interests and for all the questions, their initial question raised from March that motivated this webinar.
Thank you very much, Christophe.
Thank you.
It's my turn to thank you very much, and to you also, Julien, Xavier, and William, for this very qualitative presentation. I thought it was very interesting and very high quality material, so thank you very much. Thank you also for the conclusion, Christophe, saying that DVB is the right place to have all those technologies, or very trendy technologies, gathered together, so that cross-cutting technologies needs to fit together, and this is our current challenge in DVB. So at last, I will encourage any company who have an interest in this technology to participate if they are members, or to join DVB. Thank you very much.
Thank you.
And with that said, we will say goodbye to all of our panelists. We will have the slides on the website within about 30 seconds, and the video should be there later on. Thank you all for joining us, and I hope you'll be able to join us for another DVB webinar after the summer holidays. Goodbye.